Hello friends, now we are going to solve some problems related on EMF and terminal voltage. So last video we have discussed about what is EMF. So this is a maximum potential difference when the circuit is open, and next is a terminal voltage. This is a potential difference between the two electrodes when the circuit is closed. So related to that, uh, we are now solving some problems. So in the first problem they have given the battery of EMF is 10 volt, and internal resistance, that is small r, is 3 ohm and is connected to a resistor. The current I flowing through the circuit is 0.5 ampere, and the terminal voltage of the battery when the circuit is closed. So they have asked us to find out a VT. So we know that VT is equal to EMF minus IR. So this IR is a potential drop across this battery cell. So here in this case they have given the value of EMF, that is a 10, and they have given a value of a current I, and resistor's value is 3 ohm. So 10 minus 0.5 into 3 is nothing but 1.5. So 10 minus 1.5 is 8.5 volt. So this terminal voltage is 8.5 volt. So this is a simple one. So direct question is there. So with the help of this formula we have solved. So next one. The next problem is the battery is having a EMF 5 volt. So this is given data is, first we will write the given data. So they have given battery having a EMF 5 volt, and internal resistance, that is small letter r, is 0.5 ohm, is connected to with a resistance of 4.5 ohm. So they have connected another resistance. Then the voltage at the terminal of the battery is, so they have asked us to find out the terminal voltage, that is VT. So here we need to calculate a current flowing through this circuit. So let me draw a diagram of this problem. So this is a battery, so having a 5 volt, and this is having a resistor is how much, 0.5, and there is one more resistor, so that is 4.5. Then there is a voltmeter, so here we are measuring the voltage. So they have asked us to find out the voltage terminal here, VT value. So to solve this, the first thing we need to calculate a current flowing through this circuit. See, we have VT is equal to E minus IR. So from this, E is given and internal resistance R is given, but we don't know the value of I. So to calculate this I, see here the total resistance in the circuit becomes, total resistance in the circuit is R plus R. So when I do this, R value is 0.5 and 4.5. So capital R value is 4.5 and small r is 0.5. So the total is, resistance is 5 ohm. The next is I need to find out I. So the I is equal to, what I can write is E divided by total resistance, that is R plus R. So that E is 5 volt and total resistance is 5. So 5 get cancelled. So the 1 ampere is flowing here. So put this in equation number 1. So Vt is equal to E is 5 volt, I is 1 ampere and small letter r is 0.5. So 5 minus 0.5 is multiplied with 1 is equal to 0.5. So 5 minus 0.5 is 4.5 volt. So this voltage drop is 4.5 volt. So in this problem हमने क्या किया कि वो लोग व्हाट दे हैव आस्क्ड इज द टर्मिनल वोल्टेज. तो इसके लिए ना हम लोग डायरेक्टली इक्वेशंस पुट किए, दैट इज वी टी इक्वल टू ई एम एफ माइनस internal resistance is multiplied with the current. This is nothing but this IR is representing a voltage drop across the battery cell. ये बैटरी सेल का जो वोल्टेज ड्रॉप होता है ना उसका वैल्यू है IR. सो इधर हमको E का वैल्यू पता है और स्मॉल r का वैल्यू पता है, मगर द टोटल करंट फ्लोइंग थ्रू दिस सर्किट उसका वैल्यू पता नहीं है. तो उसको पहले हम लोग कैलकुलेट करते हैं. तो पहले हम लोग कैलकुलेट करने के लिए टोटल रेजिस्टेंस इन द सर्किट हम लोग फाइंड आउट करते हैं. सो दैट इज आर प्लस आर. तो वो करने के बाद टोटल रेजिस्टेंस कितना हो रहा है इस सर्किट में कि 5 ओम टोटल सर्किट है. तो आई इज इक्वल टू वी बाय आर फ्रॉम दी ओम्स लॉ. मगर हम लोग इधर हमारा वोल्टेज ड्रॉप कितना है कि EMF है और डिवाइडेड बाय इंस्टेड ऑफ आर वी आर टेकिंग अ आर प्लस आर. So R is external resistance connected and a small r is small internal resistance. So here I have made a mistake. See this ohm I have mentioned it as a, sorry, instead of ohm मैंने क्या किया हूँ 4.5 volt लिखा हूँ. तो this resistor SI unit is 4.5 ohm. तो I equal to E by R करके हमने 1 एम्पियर करंट इस सर्किट में फ्लो हो रहा है. तो उसका वैल्यू हमने फाइंड आउट किया. तो बाद में हमारा मेन इक्वेशन में मैंने सब्स्टिट्यूट किया. तो वी टी इज इक्वल टू 5 माइनस 1 इंटू 0.5. सो 1 is multiplied with a 0.5, so 0.5, so 5 minus 0.5, what we got is 4.5 volt. So this is also a simple problem. Next one is a cell whose EMF is 2 volt and internal resistance is 0.1 ohm and is connected to 3.9 ohm. So the cell whose EMF they have given a 2 volt and internal resistance is 0.1 ohm and is connected to external resistance, that is 3.9 ohm. The voltage across, so they have asked us to calculate terminal voltage. So we know the formula for a terminal voltage is E minus I by R. ये प्रॉब्लम भी हमारा जो लास्ट प्रॉब्लम को मैच करता है. सो हियर हमको फर्स्ट व्हाट वी नीड टू कैलकुलेट इज I. सो द I इज E डिवाइडेड बाय R प्लस R. सो E का वैल्यू हमारा 2 वोल्ट है और कैपिटल R इज 3.9 and small r is 0.1 ohm. So 2 divided by 3.19 और 0.1 का वैल्यू कितना होता है 4 होता है. So 1 by 2, so that is nothing but 0.5 ampere is flowing in the circuit. So directly we can substitute I value in the equation number 1. So Vt is equal to E is 2 volt minus I is nothing but 0.5 and small r value is 0.1. So 0.5 into 0.1 is 0.5 into 0.1 is 0.05. So 2 minus 0.05 will give us 1.95 volt. So our VT value is 1.95 volt. Next one. So next one is very interesting. See here they have given us a cell of EMF is 1.8 volt, and again there is an internal resistance 2 ohm and is connected in a series with the ammeter resistance, so that I am mentioning it as a RI, so that is 0.7 ohm, and a resistor, there is an external resistor that is 4.5 ohm as shown in a figure. So then they have asked us to find out potential difference across the terminal of the cell. So this terminal of the cell is nothing but our VT value. So we need to calculate here also VT, and we have formula VT is equal to E minus I by R. So again we need to calculate total current flowing in the circuit. So to calculate that one, we need to calculate a total resistance inside this circuit, total resistance inside the circuit. So here there are three resistance, one is a internal resistance and one is a ammeter resistance and one is a external resistance. So this R value is how much? 2 ohm, and ammeter resistance is 0.7 ohm, and this is 4.5 ohm. So after adding all these things, what we got is total is 4.5 is 6.5, so 0.7 is nothing but 7.2 ohm. So the total resistance in this circuit is 7.2 ohm. So we need to calculate I here, so I will becomes E divided by total resistance inside this circuit, total R value. So this E is nothing but 1.8 volt. The total resistance is 7.2 ampere, sorry 2 ohm. So volt divided by 7.2 ohm. So this will gives us 0.25 ampere. So now हमको I का वैल्यू पता चल गया, सो इंटरनल रेजिस्टेंस का वैल्यू भी पता है और E का वैल्यू भी पता है. सो ऑल दीज थिंग्स फ्रॉम इक्वेशन नंबर 1, so we can directly substitute Vt is equal to EMF is 1.8 volt minus current का value is 0.25 ampere into internal resistance, so small r is 2 ohm. So this 1.8 as it is, 0.25 into 2 is nothing but 0.5 into 2 is 10224. So this will becomes 0.5. So 0.25 into 2 is 0.5. This is correct. And now 1.8 minus 0.50 will becomes V2 value is 1.3 volt. So सभी प्रॉब्लम्स में क्या है कि हम लोगों को टर्मिनल वोल्टेज फाइंड आउट करने का है. तो उसके लिए ना एक एक प्रॉब्लम में डायरेक्टली आई वैल्यू गिवन है और आर वैल्यू भी गिवन है, स्मॉल आर इंटरनल रेजिस्टेंस. सो डायरेक्टली हमने वीटी कैलकुलेशंस किया. सम ऑफ द प्रॉब्लम में क्या हुआ कि दे हैव गिवन सम एक्सटर्नल रेजिस्टेंस। सो इंटरनल रेजिस्टेंस को एक एक्सटर्नल रेजिस्टेंस दिया हुआ रहता है। सो दोनों रेजिस्टेंस को ऐड करके हम लोगों को टोटल रेजिस्टेंस इनसाइड द सर्किट फाइंड आउट करने का है। बाद में आई वैल्यू फाइंड आउट करने का है। सो ओम्स लॉ के हिसाब से आई इज इक्वल टू वी डिवाइडेड बाय आर हम लोग यूज करते हैं। इधर वोल्टेज कौन सा रहता है, ईएमएफ का रहता है, तो इसके लिए ना हम लोग आर प्लस आर लेते हैं, क्योंकि वो ईएमएफ का इंटरनल रेजिस्टेंस भी रहता है। तो वो कैलकुलेशंस करके हम लोग आई फाइंड आउट करने का, बाद में हम लोग डायरेक्टली सब्स्टिट्यूट करके वीटी फाइंड आउट करने का। थैंक यू।